Now, welcome all of you. Now, in B.Sc part first, we have seen in 4 papers. In semester first, we have seen 2 papers, general physics and optics. In semester 2, we have to see also 2 papers, thermodynamics and electricity magnetism. In the same way, in B.Sc part 2, we have to see we have to study a 4 paper. In semester 3rd, we have to see 2 paper, as well as in semester 4th, we have to see a 2 paper. In the semester 3rd, there are 2 paper, paper number 5th and paper number 6th. Paper number 5th, that is a paper 5th, it is a general physics, and paper 6th, it is a electronics. Now we here in paper electronics, paper number 6, paper electronics, number of topics that have taken by me. That is transistor amplifier, first topic. After that, number of that is only one topic will teach you Professor Zamne madam only instrument, and all other topic we have see the syllabus of this paper, and here new syllabus, B.Sc syllabus, the university syllabus is let us start from this year. Therefore, I will share the syllabus on this WhatsApp as well as Google Classroom. Now, here let us start. Here, electronics. Physics paper 6th, topic first, transistor amplifier. Before this, we have to see that what is a electronics. We know that electronics is the branch of a physics which deals with study of a flow of electron into vacuum or gas or semiconductor. We know that electron in atom that can be revolved around the nucleus, and such electron, free electron, this is the bound electron to that atom. But when we consider the free electron, how such electron that can be flow in a vacuum, in gas, in semiconductor, that or any metal, that means flow of electron through the gas, vacuum or semiconductor is called as a electronics. Now, an electronic device are being used in almost industry. Here we have to study the electronics. For quality control, for automation, number of electronic device that can be used in industry. Now, electronic has gained the most importance in industry. Now, here we have to study the electronics. How we can study the electronics? You know that in electronics, mute kara sound. In electronics, there are in electronics number of devices, number of instruments that can be designed, that can be fabricated, that can be discovered. Now, in 12th standard, we have seen in the electronics, also 11th standard. Now, in B.Sc part first, we have seen only the transistor. But in B.Sc part 2, we have to see the certain topic, 6 topics, in which we have seen the electronics. Here, in electronics, only few components, that is a transistor, transistor, diode, also UJT, SCR, FET. These devices that can be on this device, electronics is based. And therefore, here we have to say that only this component, that means transistor, diode, FET, SCR, so these are the important components. On this component, electron that can be based. Resistors, capacitors, inductors, these are the passive components. Diode, transistor, UJT, FET, these are the active components. We in B.Sc part, first we have seen what are the active component and passive component. What is the difference between active component and passive component? Only these components are included in electronics. And by using this component, a number of instrument that can be fabricated, number of instrument that can be designed. Therefore, which are the instruments that can be included in the electronics? Which is instrument? In our home, number of electronic instrument. One that computer is an electronic device. TV receiver, it is also electronic device. In your pocket, there is a mobile. This mobile is also electronic device. Therefore, how this mobile becomes a small? How this laptop or desktop that can be becomes a small? In a laptop or desktop, there are number of a transistor. By using, we can make a number of electronic circuit, such as amplifier circuit, audio amplifier circuit, video amplifier circuit, detector circuit, number of circuits that can be built by using transistor, diode, resistor, capacitor, and this circuit, by using circuit, a whole this instrument, that is a TV receiver, radio receiver, on that radio receiver, it is also electronic instrument, mobile, computer. That means all these electronic instruments, all world, or in all field, electronic instrument, in all industry, electronic instrument that can be used. And therefore, only this component, that means in paper 6, we have studied 6 topics. That means this 6 component, how much important. And on this component, all electronic is based. If we study carefully, if we understand the concept of this component, then we can easily understand the electronics subject. Now, let us start a first topic, transistor amplifier. Now, let us introduction. In B.Sc part first, we have seen a transistor. In the 11th standard, we have seen a transistor. But in 11th or 12th standard, or in B.Sc part first, we have to see the next. What is transistor amplifier? In B.Sc part first, we have seen the configuration of a transistor, construction of a transistor, that means structure of a transistor, its application, now its configuration, its working. In B.Sc part first, we have seen. Now, but here we have to see a transistor amplifier. How number of amplifier circuit, and how transistor that can be used in this amplifier circuit, and working of this amplifier circuit. Also, in this topic, here we have to see the oscillator circuit, number of that means differential amplifier. That is, these articles come into this topic. And on this transistor amplifier, a next topic is based, oscillator. That means oscillator. Oscillator is nothing but it is amplifier, in which feedback is fed from output to input. Therefore, in electronics, each topic is dependent on other topic. That means to understand the second topic, it is essential to know, it is essential to knowledge of the topic number 1. Therefore, here when the lecture of electronics is start, at that time all students remain present. When we gap one of the lecture, then we does not understand the next lecture. Therefore, it is essential to remain the present. Now, in the introduction, initially we have to see transistor is a semiconductor device. In electronics, electronics is built of a only semiconductor material. Therefore, transistor is also semiconductor device. Transistor is also called as a bipolar junction transistor. What is the name of the transistor? Bipolar junction transistor. There are two types of a transistor. Why it is called as a bipolar junction transistor? Transistor is a semiconductor device. It is also called as a bipolar junction transistor. When we see this construction of a transistor, now here in the construction, this is the NPN transistor, this is the PNP transistor. In NPN transistor, P-type material is sandwiched in between two thick N-type material. This is the P-type material. It's sandwiched in between two thick N-type material. The resulting device is called as a NPN transistor. Such a device is called as a NPN transistor. Similarly, how we can explain the PNP transistor? In PNP transistor, thin N-type material is sandwiched in between two thick P-type material. Thin N-type material is sandwiched in between two thick P-type semiconductor material. The resulting device is called as a PNP material. Now, also we have seen that this region is called as the emitter region. Therefore, terminal taken from this emitter is called as a emitter region is called as the emitter. This region is called as a collector region. Collector region. The function, we know that the function of a collector. Similarly, here this region is called as a collector region. Terminal taken from this collector region is called as a collector. This is the electrode. This is the terminal called as a collector. And middle region is called as a base region. This is the base region. And this is the terminal called as a base. Now, we know that when we study the semiconductor, in the semiconductor, it is the material whose conductivity lies in between insulator and conductor. We know that the insulator, its resistivity is infinity. We know that the conductor, its resistivity is 0. That means conduction of electron takes place in conductor. In insulator, what happens? In insulator, no current flows, no electron flows. Therefore, its resistance is infinite. Now, here there are two types of a semiconductor. One is intrinsic semiconductor, another is extrinsic semiconductor. Intrinsic semiconductor, it is in purely form, is called as the intrinsic semiconductor. Germanium, silicon, it is in pure form. Then it is called as the intrinsic semiconductor. And the extrinsic semiconductor, when semiconductor, it is doped with some impurity. When pentavalent impurity is doped, pentavalent impurity, that means in the pentavalent impurity, in this impurity there are 5 electrons in its outermost shell. But in carbon, in case of a germanium, in case of a silicon, there are 4 electrons in its outermost shell. Therefore, when pentavalent impurity that can be added, 1 electron becomes excess. And how much impurity that can be added, how much atom of impurity that can be added in pure semiconductor, according to this, the concentration of electron that can be increases. And such a semiconductor is called as a N-type semiconductor. Therefore, in N-type semiconductor, concentration of electron is large as compared to hole. And here, That means concentration of electron is large. Therefore, majority carrier in N-type semiconductor are electrons, and minority carrier in N-type semiconductor, that is होल्स. मायनॉरिटी कॅरियर काय राहतात? होल्स राहतात. कशामध्ये? एन टाइप सेमीकंडक्टर मध्ये. मेजॉरिटी कॅरियर काय राहतात? इलेक्ट्रॉन राहतात. सिमिलर टू एन टाइप सेमीकंडक्टर, हाऊ वी कॅन prepare a p-type semiconductor? For this purpose, which type of impurity that can be added in pure semiconductor? Trivalent impurity or pentavalent impurity? Trivalent impurity that can be added. When we added a trivalent impurity in p-type in pure semiconductor, then in trivalent impurity there are 3 electrons in its outermost orbit. Therefore, there is a vacancy of 1 electron. And due to vacancy of 1 electron, when it bonds to the other, at that time there is a formation of a hole, and it forms a p-type semiconductor. And therefore, in p-type semiconductor, the majority carriers are holes. That means concentration of a hole in p-type semiconductor is large as compared to electron in p-type semiconductor. Now, here we have to study this transistor is called as a bipolar junction transistor. Now this is the NPN transistor, this is the PNP transistor, this is the emitter region, this is the base region. This junction is called as the emitter junction, and this junction is called as a collector junction, junction between base and collector. This is the junction, collector junction. This is the junction between emitter and base, emitter junction. That means it has a 2 junction. That's why bijunction. 2 junction right now. Therefore, it is called as a bijunction. Now, current flow in the transistor, in NPN transistor, current flow due to the electron. A small current flows due to the minority carrier as a whole. And therefore, here we have to say that there are 2 polarity. Current flow due to the 2 polarity. Which polarity? Positive polarity, negative polarity. That is positive. Hole is the positive, electron is the negative. That means due to the electron as well as due to the hole, current flows. That's why it is called as a bipolar. That means current flows in this transistor due to the 2 polarity. That's why it is called as a bipolar. It has a 2 junction, emitter junction, collector junction. That's why the bijunction. Transistor, the device has a 3 terminal. Emitter, base, collector. That's why it is transistor. This is the base terminal. This is the collector terminal. This is the emitter terminal. That's why it is called as a bipolar junction transistor. This is the NPN transistor. This is the PNP transistor. In the NPN transistor, the direction of arrow, it is in outward direction. The direction of a arrowhead on the emitter, it is in which direction? Outward or inward direction. The direction of arrow, it is in NPN transistor, it is in outward direction. Also, in case of a PNP transistor, the direction of a arrowhead on emitter, this is the emitter terminal, it is in inward direction. Therefore, here we have to say that in case of a PNP transistor, the direction of the arrow, it is inward direction, and this direction that can be used as the direction of a conventional current. You know that what is the direction of a conventional current? Current flows from high potential to the low potential, high potential to the low potential. Positive potential is a high potential. Negative potential is a low potential. That means current flows from positive to negative. Water flows from high level to low level. In the same way, current flows from high potential, positive potential to the negative, high potential to the low potential. Now here we have to say that this is the transistor. This is the structure of a transistor. This is the construction of a transistor. And here we have to say that in structure, this region, collector region, is large as compared to the emitter region. Emitter region and collector region, which are made by using same material, but collector region, it is made large as compared to the emitter region. In order to dissipate the heat, this collector region that can be made a large. Heat dissipate होण्यासाठी the collector region काय केलेला आहे? Made a large. This is the physical property. Now, how physically look at transistor? That means collector region is large, emitter region is small, base region it is very, very thin. Now, after that, we can see the electrical property. In electrical property, here we have to say that this region, emitter region, it is heavily doped. Heavy doping, that means it's a concentration of a carrier, it becomes large. Base region, it is lightly doped. And collector region, it is moderately doped. That means here we have to see the physical property and electrical property. In physical property, we can say that the collector region is made large as compared to the emitter region in order to dissipate the heat. After that, we can see the electrical properties. In the electrical property, we can say that emitter is a heavily doped or lightly doped? Heavily doped. Base region is this base region is lightly doped. This is heavy, this is light, this is moderate. Collector region is a moderately doped. Now, this is about the introduction of a transistor. In B.Sc part, first we have seen what is a transistor, what are the different types of a transistor, its a construction of a transistor, its a physical properties. After that, here we have to see the biasing of a transistor. These are the transistors. Here, other types of a transistor. Now, this is the germanium transistor. Some transistors are germanium, some are the silicon. These are the power transistor. This look like a transistor in this way. Now, in oscillator circuit, in biasing circuit, in a different oscillator, this shift oscillator, full oscillator, other type of oscillator, this transistor we have to perform the practical. At that time, this transistor that can be used. This is the germanium transistor. This SL100 transistor. B.Sc548 transistor. This transistor is a B.Sc519. This is the 257 transistor. We can, this is the structure. We can look such type of a typical transistor package. These are the power transistor. Now, here we have to see transistor biasing. Now, in our syllabus, now this is the opening of this topic. Transistor biasing. You know that diode is a forward biased, diode is a reverse biased. When diode is forward biased, at that time, anode is connected to the positive terminal of the battery supply, cathode is connected to the negative terminal of the battery supply, then diode becomes a forward biased. Forward biased. Now, this is the biasing of the transistor. Now, here we have to see this is the simplest biasing of a transistor. Before study the simplest biasing of the transistor, we can see what is meant by biasing of the transistor. Biasing of a transistor is nothing but proper voltage of a proper polarity is applied to the terminal of the transistor. बेसला कुठलं व्होल्टेज अप्लाय करायचं, कलेक्टरला कुठलं व्होल्टेज अप्लाय करायचं, इमिटरला कुठलं व्होल्टेज अप्लाय करायचं, प्रॉपर व्होल्टेज अप्लाय करायचं. नाहीतर जेवण भरपूर आहे म्हणून भरपूर खायचं, त्याला म्हणजे काय उपयोग? किती खायचं, लिमिट मध्ये खाल्लं पाहिजे ना, हे महत्वाचं आहे. नाहीतर लिमिटच्या बाहेर जर जास्त खायचं म्हणलं तर आणखी अवघड होऊन बसत. ते काय प्रॉपर बायसिंग होत नाही. आणि बायसिंग असल्याशिवाय ट्रान्झिस्टर ऑपरेट होत नाही. मोटरसायकल जर ऑपरेट करायची असेल तर वर्किंग कंडिशन मध्ये असायला पाहिजे असेल तर त्याला बायस केलं पाहिजे ना मोटरसायकल. पेट्रोल टाकलं पाहिजे तर ती बायस होईल. आपल्याला जर काम करायचं असेल, लेक्चर ऐकायचं असेल, घरी काम करायचं असेल, शेतामध्ये काम करायचं असेल तरी सुद्धा आपण बायस झालं पाहिजे. बायस झालं पाहिजे म्हणजे जेवण केलं पाहिजे, प्रॉपर जेवण केलं पाहिजे. मग हाऊ वी कॅन प्रॉपर कसं जेवण करता येईल आपल्याला? नाहीतर काय बी खाऊन चालतंय का आपलं? तब्येत आपली कशी चांगली राहिली पाहिजे, आपलं आरोग्य कसं चांगलं राहिलं पाहिजे या कोरोनाच्या काळामध्ये. त्यासाठी आपण काही काही व्हिटॅमिनच्या गोळ्या घेतल्या पाहिजेत, आपली इम्युनिटी पॉवर वाढवली पाहिजेत, काढा वगैरे घेतला पाहिजे, चांगले म्हणजे व्हिटॅमिनच्या गोळ्या घेतल्या पाहिजेत, तर आपली इम्युनिटी पॉवर वाढेल ना. त्यालाच बायसिंग. म्हणजे भरपूर गोळ्या घेतल्या म्हणजे इम्युनिटी पॉवर वाढते असं नाही. प्रॉपर व्यवस्थितरित्या जर घेतलं तरच आपली इम्युनिटी पॉवर वाढेल, त्यालाच बायसिंग. म्हणजे बायसिंग ऑफ ए ट्रान्झिस्टर, जसं आपल्याला बायसिंगची गरज आहे तसं सिमिलर वे बायसिंग ऑफ ए ट्रान्झिस्टर इज नथिंग बट द प्रॉपर व्होल्टेज ऑफ ए प्रॉपर पोलॅरिटी इज गिवन टू द टर्मिनल ऑफ ए ट्रान्झिस्टर. Proper voltage of proper polarity is given to the terminal of a transistor. And here we have to say that simplest biasing circuit, this is the simplest biasing circuit. In simplest biasing circuit, this is the base, this is the emitter, this is the collector, this is the transistor. Collector is biased by using this battery supply. Emitter junction is biased by using this battery supply. And here we know that biasing in normal simplest biasing circuit, emitter junction is always forward biased. In B.Sc part first we have seen I talk frequently for biasing. Emitter junction is forward biased. Collector junction is always reverse biased. For proper biasing of a transistor, in normal operating condition of a transistor or for proper working of a transistor, emitter junction is always forward biased, collector junction is always reverse biased. And here we can study the simplest biasing circuit, that is emitter junction forward biased. How we can make the emitter junction forward biased? By using this battery supply, we can make the emitter junction forward. This is the NPN transistor. Emitter region is N region, base region is P region, collector region is a N region. Therefore, here we have to say that emitter region is N region, base region is P region. Therefore, we can apply positive voltage to the P region, negative voltage to the emitter region. Then here we have to say that this emitter junction becomes a forward biased. Similar to the emitter junction becomes forward biased. Collector junction that can be made a reverse biased. How we can make the collector junction reverse biased? Positive voltage is given to the collector. Collector is a N type and positive voltage given it to the N type material. And here this is the